The question is as follows: express 2x squared positive 12x positive 11 in the form 2 of x positive a the whole squared positive b, where a and b are constants. And the function f is defined, or I would say, let me write the function 2x squared positive 12x positive 11 for x less than equal to negative 4. They are asking us to find f inverse of x and state the domain. This is one part, and part B, given g of x is 2x negative 3 for x less than equal to k, they are asking us to solve f of g of x is equal to 193 for k being equal to negative 1. Okay, so let's work out the first question. We are asked to express 2x squared positive 12x positive 11 in the form of 2 times of x positive a raised to the power of 2 positive b. So what I would do is I would take 2 out and rewrite this as x squared positive 6x positive 11. Then you consider x squared positive 6x. Now take the coefficient of x and you divide by 2. So this is done on the rough side. We don't have to show it over here. So you divide by 2, you get 3. Now add, now let me just take this to be say equal to 0. Now add 3 squared and subtract 3 squared. Okay, so this is going to be x squared positive 6x positive 3 squared. You're subtracting it, right? So that means 3 squared will be over here. Now this can be written as a perfect square. Well, how is that? This is going to be x positive 2, or I would say x positive 3. How do I say x positive 3? You have to put in this quantity, whatever you are utilizing as the coefficient of x, and then you square it, and then of course you have a 3 squared. Now if you were to rewrite this x squared positive 6x, this can be now rewritten as x positive 3 the whole square. Now you have this 3 squared, right? You bring this 3 squared out, right? So this is the, or in other words I would say x squared positive 6x as the representation x positive 3 whole squared negative 3 squared. So take this and replace this. So this is equal to 2 times of x positive 3 whole squared negative 3 squared. I'm going to take it as 9, and you have positive 11. So distribute 2. This is going to be 2 times of x positive 3 whole squared negative 2 times 9 is 18 positive 11. This could be rewritten as 2 times of x positive 3 whole squared negative 7. Now since we have to write this in this form, I'm going to rewrite this as 2 times of x positive 3 the whole squared positive of negative 7, which is of the form 2 times of x positive a the whole squared positive b, where a is equal to 3 and b is equal to negative 7. So that completes the solution for the first part. Now we need to move on to the next part. Now we have to get f inverse of x and state the domain. So let's do that. Now we need to get f inverse of x. So what have we got? We got f of x to be equal to 2 times of x positive 3 whole square negative 7, right? Now this can be rewritten as y is equal to 2 times of x positive 3 whole square negative 7. Now replace x by y and y by x in this above. So you have, and then you rewrite for y. after you have done that, rewrite for y. So that is how we get f inverse of x. So this is going to be x is equal to 2 times of y positive 3 the whole squared negative 7. I can rewrite this as x positive 7 is equal to 2 times of y positive 3 the whole squared. You bring the 2 down, so it's going to be x positive 7 divided by 2 is equal to y positive 3 whole squared. I prefer to write it like this: y positive 3 the whole squared is equal to x positive 7 divided by 2. Move this 2 to the other side, so you get y positive 3 is equal to square root of x positive 7 divided by 2. Move the 3 to the other side, so y is equal to square root of x positive 7 divided by 2 negative 3. Right, now we need to see something. So this is going to be my f inverse of x. F inverse of x is equal to square root of x positive 7 divided by 2 negative 3. Now since I've got square root, you got a plus and a minus, so that is going to be my f inverse of x. Now we need to calculate the domain. Now it is given that f of x is defined for all values of x less than equal to negative 4. So if we were to draw the number line, I take this as 0, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, so on and so forth. So the function is defined for all x less than equal to negative 4. So that means we are moving towards this end, right? So I will mention to you that important information. Let me also go back to the inverse. F inverse of x is square root of x positive 7 over 2. Now we can take it as plus or minus negative 3. Now what is more important here is f inverse of x will be valid for x positive 7 greater than equal to 0. This means for x greater than equal to negative 7. But don't go and state that x greater than equal to negative 7 will be the domain for f inverse of x. We cannot come to that conclusion. Why? Because as I mentioned to you, x is less than equal to negative 4 for f of x. Now since f of x is x squared positive, it's actually 2x squared positive 12x positive 11 for x less than equal to negative 4. This means f of negative 4 is equal to 2 times of negative 4 the whole squared positive 12 of negative 4 positive 11, which will give us a value of approximately, let me calculate this value. So what is this going to be? So 16 to 32, and this is 48 plus 11, and 43 minus 48, which is negative 5. So what do we see here? The range of f of x is actually from negative 5 to infinity, right? But as I mentioned to you, f inverse of x is taking all values of x greater than equal to negative 7. So let me draw the graph 0, 1, 2, 3, and negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7. So all x greater than equal to negative 7. So from here we are moving on for the inverse, f inverse of x. But for f of x, the range is starting from negative 5 to infinity. So negative 5 is over here, right? So from here onwards we are moving up. So we need to take this intersection, and then you conclude, therefore the domain of f inverse of x is all values from negative 5 to infinity. Now this is a very important step in this question. Now we have to move to the next part or the last part, which is as follows. For k equal to -1, we are asked to solve f g of x is equal to 193. And prior to this, we are given g of x as 2x -3 for all x less than equal to k. So this is actually the boundary condition, or I would say the condition given. So let me move on to the new page. So let me write what we have got. So already we have got f of x. So f of x is 2 times of x positive 3 the whole squared -7, and g of x is 2x -3. So f g of x is nothing but f of g of x, which is equal to f of 2x -3. Take this and substitute here. So this is going to be 2 times of 2x -3 positive 3 the whole squared -7, and this has been given to be as 193. So negative positive goes off. This will give me 2 times of 2x the whole squared -7 is equal to 193. 4x squared times 2, that's going to be 8x squared -7 is equal to 193. Move this 7 to the other side. So you get 8x squared is equal to 193 plus 7. That means 8x squared is equal to 200. So x squared is equal to 200 divided by 8. 4 divides here 2 times, 4 divides here 50 times, 2 divides here 25 times. So x squared is equal to, or I would say, let me write this fashion. X squared is equal to 25. So x is equal to root of 25. Why am I writing like this? Because to show you that we are getting two values, plus 5 and x is equal to -5. But g of x is equal to 2x -3 is defined for all x less than equal to k, and given, what is given, k is equal to -1 means all x less than equal to -1. This means all x and x less than equal to -1 means where is the value? So -2, -3, -4, -5. You got 1, 2, 3, 4 and 5. So 5 is over here, -5 is over here. We are looking for all x less than equal to -1. So we are moving towards this side. So we drop positive 5s and we take x is equal to -5 as a solution, and you box it. That's the solution for this question. We move on to the next one.